Now look into this situation. Here we have this arrangement, and here it is given that the key is being tapped and it is just closed. So when we just close the key, then what will happen? The current will flow in this circuit in the direction shown by these arrows, right? And when it is just closed, so we can say that the current was not there and current has just appeared. So when the current has just appeared means what? Magnetic flux appears in this loop. And if you look at the direction of the arrows means the direction of the current, so the corresponding magnetic flux will have this situation. So the magnetic flux will be in this direction, right? See, if you have the curl of your right hand in the direction of the current, then the thumb is pointing towards the left side. So the direction of magnetic flux, or you can say magnetic field lines, is like that. So initially the magnetic field is trying to increase. So as soon as the key is tapped, the magnetic field lines appears means there is an increase in flux in this, say, this loop 1. Now the direction of induced current that we have to find in this loop, so the direction of the induced current in this loop XYZ will be such that it will not let the flux to increase. So for that it will induce, that induced current will create a magnetic field in the direction opposite to that. So we need a magnetic field, induced magnetic field in this direction. So in order to get this induced magnetic field, the direction of the current must be like that. Okay, so you can use your right hand again. So curl your fingers in the direction of the current. Then this thumb is pointing towards the induced magnetic field so that it will oppose the increase in magnetic flux. So the direction of the current, or the sense of rotation of current, can be said to be X, Y, Z. Okay. Similarly, if we look in this part D, here in this part D, if you observe carefully that it is given rheostat setting being changed and how this setting is being changed. So look at this arrow. This arrow is towards left or in this direction, and this slider is moving in this direction. This means there is a decrease in the resistance. When there is a decrease in the resistance, this means the current that is flowing in this loop, that current is increasing. Now look at the sense of the current. So it will lead to the magnetic flux in this direction. It will lead to magnetic flux in this direction, right? So as the current is increasing, so this magnetic flux is increasing. So we can say that the current that is induced in the facing loop will be such that it will not let the magnetic flux to increase. So the direction of current must be like that. So this is the direction of induced current. This is the direction of induced current, and it will create a magnetic field in this direction. That is the induced magnetic field, which will oppose the increase in the magnetic flux. So if we look at here, so the sense of rotation of the current will be again X, Y, Z, right?